In this video, we're going to be talking about the skill of area involving rectangles and circles. Off to the side, I've listed your formula for rectangle and for circle, but both of those obviously can be found on your formula sheet. In our first example, it says a rose garden is formed by joining a rectangle and a semicircle as shown below. The rectangle is 21 feet long and 14 feet wide. Find the area of the garden. Use the value 3.14 for pi and do not round your answer. Be sure to include the correct unit in your answer. We're talking about area, so our correct answer's label will have a squared with it. In this case, feet squared. Okay, so we're going to use a shapes plan to solve for the area of the entire garden. The entire garden is basically two shapes that I'm hoping we recognize. You have a big rectangle here, so we'll find the area of the rectangle using your formula. And then we have another shape that continues to be part of the garden, and that's a half circle or a semicircle. Okay? The formula I've given you as it stands now is for an entire circle, pi r squared. So if we only want half of that circle, we're going to take that formula, the entire circle, and divide it by 2. So that's our formula for a semicircle or a half circle. Okay, now we're ready to begin. So area of the entire garden, the garden's in these two parts, the rectangle and the semicircle. So we're going to find the area of the rectangle, and we're going to find the area of the semicircle, and we're going to add those two areas together. Okay, when we add those two individual areas, that will give us the total area of the rose garden. All right, let's get down to business. Using our shapes plan, the rectangle is base times height, and the base of the rectangle is 21 feet, just like the top of it, and the height of the rectangle is 14. So if you have your calculator handy, go ahead and do 21 times 14. If not, please pause the video and go get your calculator. In your calculator, 21 times 14 is 294. So the area of the rectangle, the whole thing there, is 294. And now we're going to find the area of the semicircle using our semicircle formula. So pi times radius squared, and all of that divided by 2. Okay? They said to use 3.14 for pi, and we're squaring the radius. Okay? We need to figure out what is the radius of the semicircle. Okay? We know that the left side of the rectangle is 14, so the right side of the rectangle also has to be 14. Okay? So if this is a semicircle, you can imagine that there's a full circle tucked inside. We don't want the full circle, just the half circle, but that will help us to determine the radius. Okay, so if on the full circle it has a diameter straight through the center of 14, then the radius is just half of that 14. Okay, so our radius here is 7. If you're not sure, or I went a little too fast on the radius, please pause or rewind a little bit so you can think about or hear that explanation again. Okay, because they didn't straight up give you the radius of 7. You kind of had to work for that. All right, so 3.14 times 7 squared, and then the formula says divide by 2. All right, multiply exponents and divide exponents first. So 7 squared, or 7 times 7, is 49. And then I'll rewrite that here. Now 3.14 times the 49 is 153 and 8600ths, and that divided by 2 is 76.93. Okay, so area of the rectangle 294, area of the semicircle 76.93, and our shapes plan said we're adding those two numbers together. So your 76.93 plus your 294 gives us 370 and 9300ths. And as I mentioned briefly before, they want our label, which is feet, and it's area, so it's squared. Okay, so the area of the entire garden, 370 370 and 93 hundredths feet squared. Taking a look at a second example, we're going to approach it the same way with our shapes plan, but you can see that our shape is a little bit different. Okay. In this question, it says a rectangular piece of paper with a length of 40, you see that down here, and a width of 20, you see that out here, has two semicircles cut out of it as shown below. So they used to have a full rectangular sheet of paper, and then somebody came along and cut out a half circle on one side and a half circle on the other side. Okay. The question asks, find the area of the paper that remains. Use 3.14 for pi. Don't round your answer. Be sure to include the correct unit in your answer. So what we're trying to do here is we're trying to find the area of this hourglass looking part. Okay, and we're going to do that by taking our shapes plan. Area of the big rectangle, okay, and this time instead of adding the half circle on, it's being cut out of the rectangle. So cutting out means you're going to have to subtract it off. Okay, so area of the rectangle, subtract, we have a half circle here and the same half circle over here. So if you put two halves together, it makes one whole. Okay, so instead of subtracting out two semicircles individually, we're just going to subtract out the circle. Okay, so rectangle minus the two semicircles. All right, so area of the rectangle is base times height. Area of the circle is pi r squared. Okay. The base of the rectangle is 40, and the height of the rectangle is 20, just like they mentioned. 40 times 20 is 800. 4 times 2 is 8, and then tack on those two zeros. Area of the circle, 3.14 for pi. We're squaring the radius. Be careful because they haven't given us the radius. However, they have told us that the height of the rectangle is 20, and that is essentially the diameter of the full circle here. Okay, so if the diameter of the circle is 20, then half of it would be its radius. So half of 20 is 10. Okay, so our radius here is 10 centimeters. Okay. If I went too fast on the radius, rewind it just a little bit and listen to that part again. All right, so our radius is 10, and we're exponents before we multiply. So 10 squared, 10 times 10 is 100, and then 100 times 3.14 is 314. Okay, 100 times 3.14, we're just moving that decimal point twice. And then our shapes plan says to subtract those two values. So 800 divided by 314. Excuse me, not divided. 800 minus 314, sorry, is 486. 486, and we need our label for area, which in this case is centimeters squared. Okay, so those two examples should get you going. This particular problem is basically a shapes plan of attack for any question they're going to give you. You want to take a good long look at the shapes that are involved in the diagram and decide what shapes are they, obviously rectangles and circles or semicircle, and then decide what you're doing with them. Are you adding or are you subtracting? All right, make sure you have your notes out if you have any additional questions for your teacher. But otherwise, go ahead and give this skill a shot. Thank you.